it's Jason here from Clean Energy Reviews, and in this video we're going to be looking at a high performance DC coupled off-grid solar system using the Victron inverter charger and the Victron MPPT solar charge controllers. So let's get into it. Now I'll just quickly run through each of the main components in this system. So of course we have the main inverter charger, which is the Victron Quattro in this case, and we have two MPPT solar charge controllers. We have the Victron BMV battery monitor and the brand new released Cerbo GX, which has only just come out. That's the central monitoring hub or communications hub. And of course we have a battery system as well, and you can see the 4 battery modules in here. Each of them is 4 kilowatt hours, so roughly 78 amp hours each. We'll also have a look at the 2 apps used for the Victron system. First being the Victron Connect app, which you can see all the individual smart devices, and the other being the Victron VRM app, which is used for system monitoring. So as I mentioned earlier, this is a DC coupled off-grid solar system which used the solar charge controllers to manage the battery charging, and a inverter charger for supplying AC power and for charging the batteries from a AC source. So this is quite different to an AC coupled system, which uses a inverter charger AC coupled with one or more solar inverters. And the other components you can see are the main battery isolator, which is a HRC fuse, meaning high rupture capacity fuses. These are 160 amps each. And we have the main isolators for the MPPT charge controllers and the PV array DC isolators for each of the controllers. And of course the main AC switchboard. So the inverter charger used in this system is the powerful Quattro 48-8000. This is a 8 kVA inverter, or roughly 6.5 kilowatt. Quattro means 4, which refers to the 2 AC inputs and 2 AC outputs. So this inverter can have a grid connection and a generator connection, and also it has 2 AC outputs. So one will be active all the time, that's AC output 1, while AC 2 is only active when there's a grid or generator connected and operating. So the Quattro inverter chargers can be set up in 3-phase or single-phase systems, and also connected in parallel for very powerful off-grid systems as well. They also have an automatic transfer switch built in for each of the 2 AC outputs, rated at 100 amps. So it's a very powerful and flexible inverter charger. So I just took the hood off so we could have a quick look inside. Now these are very well made inverters, and one thing I really like about them is that they have 2 terminal points for the battery. So in this case the larger cables are for the battery and the smaller cables go to the solar charge controllers. So it works a bit like a small DC hub, which is really handy. And they have large screw terminals for the AC as well. Very well made, heavy duty unit. So we'll just do a quick comparison to show you how the Quattro compares to some of the other leading inverter chargers on the market. Now the two MPPTs used in this system are the Victron Smartsolar charge controllers. The first one here is the 150/45 TR and the other one is the 150/60 TR. So the 150 refers to the maximum open circuit voltage and the 60 is of course 60 amp rating. So this controller can have roughly 3.4 kilowatts of solar, and the 45 amp model can have up to 2.6 kilowatts of solar at 48 volts. They can also be used with 12 volt or 24 volt battery systems as well. And this, being the latest model, has an inbuilt relay control and of course the VE Direct for communication, and very nice large terminals. And they also have an option for an add-on display which could be attached on the front here. So mounted in the middle here we have the Victron BMV 712 smart battery monitor. This can give us just the state of charge and the amount of power going to the battery, current, voltage, that sort of thing, which is all relayed through the Cerbo to the VRM portal. So we were lucky enough to get one of the first Cerbo GXs released in Australia, and so Victron have the Color Control GX, the Venus GX, and now this is the latest release, the Cerbo GX. And as you can see, it has a huge number of different ports and connections. One of the problems with the Color Control GX was it was a very limited number of VE Direct ports and USB ports, so this has solved a lot of those issues. And it also has a HDMI output for a touchscreen display if you prefer to use that rather than a phone app. For quite a small unit, it has a huge number of different ports. We have the USB ports, 3 across the front, the VE Direct ports, and of course the VE bus ports at the rear. We have a network connection, the BMS CAN inputs, which is for managed lithium batteries such as the LG Chem RESU or the BYD. And on the bottom side we have of course the power connection, and there are 2 relays, and we have digital inputs, 4 digital inputs, and 4 temp inputs and 4 tank inputs. So this can be used to manage and monitor all sorts of fuel tanks, water tanks, temperatures of different devices, so it has a huge range of options. And of course one of the best things about the Cerbo GX is that it has Wi-Fi and Bluetooth built in. So for setting up and monitoring the smart devices, we use the Victron Connect app. And here we can see the 4 smart devices, the BMV, the 2 charge controllers, and the Cerbo GX. So these are great apps which are often updated. Now as you can see, the smart BMV is set up and monitoring. It's very simple. And we can look at the charge controllers individually and we can set them up, and the battery is fairly full and it's very overcast, so we've only got a few watts trickling in at the moment. And you see the solar voltage, current, and the battery voltage. And if we log into the Cerbo GX, we can then go to the VRM online portal And here's the system overview on the VRM portal. So this is the cloud-based portal which can be accessed from anywhere, and it just has the basic information, the consumption, the solar yield, battery, state of charge, and of course we have all the advanced options and the remote console, which is very handy. So this is what could be seen on the Color Control GX. See the overview of the system and the energy flow, and it can be operated as if you had a color control. Now if we go to advanced, we can see all the different devices. If we go to the solar charger, so we can see down here the state of charge and the summary of the solar charge controllers, battery watts. This system's only just been set up, so it has quite a limited amount of information. Now I'm just going to run through how to set up a Victron BMV. This is a different system. This is my off-grid house, so the components look a bit different. So first we go to the Smart BMV, and here we can see the basic status of the system. And to set up we need to go to settings and to battery, and then we can see all the main configuration settings. Now first of all, you have to set the battery capacity to the correct value to match the battery bank. In this case we have a 234 amp hour lithium iron phosphate battery bank. The second setting is the charge voltage. Now this is usually set about 0.3 or 0.4 of a volt below the absorption voltage. In this case the absorption voltage is 56 volts. So I've set it at 55.6 volts. Now the discharge floor is the lowest state of charge you would want the battery to ever reach. In this case I've got it at 10%, although the battery is recharged by the generator when it reaches 25% state of charge. If it was a lead acid battery, the discharge floor could be 30 or 40% depending on the battery's specifications. Now the tail current is set at 4%, and this is a percentage of the battery capacity. When the charge current has dropped below this setting, the battery is basically considered fully charged. Now the charge detection time, which is set at 5 minutes, is when the tail current and the charged voltage have been met. So after 5 minutes, once the tail current is below 4% and the charged voltage is above 55.6, the battery will be synchronized to 100% state of charge. Now Perkins exponent has got to do with the efficiency of the battery when it is being charged and discharged. In this case, being a lithium battery, it's set to almost 1. because lithium is extremely efficient and has very low losses during high charge and discharge currents. If it was a lead acid battery, this value would be 1.2 to 1.25, because lead acid have much higher losses during charging and discharging. Now the charge efficiency factor is set at 99%, again because lithium batteries are extremely efficient and have very low losses. If this was lead acid, it would be around 90 to 95%. Now the current threshold is 0.1 of an amp, so anything below 0.1 of an amp is basically considered zero. Now the time to go averaging period is set at 3 minutes, and this is used to determine the time for the battery to reach its discharge floor of 10% in this case. Now there's also a few extra settings down here to do with synchronizing the battery and setting the state of charge. So you can do a manual synchronization, and you can set the state of charge to whatever you want it to be. Now the zero current calibration is to do with zeroing the shunt. This should be done after the system has first been set up, and the inverter and the other devices should be all switched off, and the only thing powered up should be the BMV before you calibrate the shunt. And that's about it. Hope that helps.